All right, thank you. Okay, so yeah, so this work is mostly done by Zipping and Zepe. Those were two of our students in the same course. And here we work on again a toolkit that will assist users, a tool that will assist users to perform housing market analysis. So this is a sort of a demo paper. Now, still understanding the housing market is important but difficult. So why is it important? I think we've all been in the situation, I guess, especially academics. We always kind of move around, and then you come to a new place, and then you somehow want to understand the housing market there. So you want to know how difficult, what is sort of what are the dynamics of the market, how to rent, how to buy and sell, all kind of aspects. Maybe what is a more safe area, what is a more, I don't know, economically justifiable area, what is like the time progression of prices and things like that. So this is really kind of what makes it, challenging. It's challenging because in practice, this means going to a lot of different websites. If you want to know how safe something is, it's a different website than trying to understand what are the prices and so on. It also means that you would like to narrow down the search based on some constraints, which are sort of defined, but perhaps you would like to tune them as you go. So this means that you would like to perform sort of iterative searching over the collected information. And all of this is highly time-consuming and laborious, and becomes really difficult when you're dealing with a lot of data size and a lot of options, and you kind of have to compare too much. It becomes just too difficult to perform sort of manually. I mean, what I guess then in practice, what we do, we just settle with some approximation of this. But I think knowledge graphs can help here. So knowledge graphs can help because they can provide a kind of a tool for flexible analysis. And so what we try to do here as a first attempt is a graph construction pipeline that can integrate information. We apply this on one specific geographical area of interest, so California, and we work with two use cases. So one is I have some criteria. Can you recommend me rental options in an area? And the other one would be sort of an analysis of the spatial temporal dynamics of the market. So the first one is kind of user driven. Well, the second one is more sort of analyzing deeper different spatial temporal dynamics. So this is sort of the pipeline that we have here. So we first start with data acquisition and cleaning. That means we have different sources. We sort of, again, aggregate them together. We perform entity linking between the sources, so entity resolution. We map the sources into a common ontology. And then we look into basically how we can exploit this. So we have a query matching set of tools, and we have a user interface and visualization tool. So in terms of data acquisition and cleaning, we work with 4 different data sets. We work with, so we want to find apartments, and for that we go to we work with 5 sources. So for apartments, we go to apartment.com and apartment finder. We get 24,000 records, a number of properties. This basically tells us which apartments are available. We get the US Census data because this one tells us things like sort of demographical aspects. So we know the race distribution, the average income, employment rate, things like that. We have like 3,000 records of those. We also looked into COVID as a hot topic these days, and sort of an approximation of something that's very kind of time dependent and relating to let's say security perhaps in some sense, or health aspects of people. And then we also looked, just for fun, for celebrities. I mean, I think it's unlikely that people look for places near celebrities, but you might want to. So we actually went to Wikipedia and we scraped places of residence of some of the celebrities. All right, so for entity linking, we used, we focused our entity linking on two aspects, so the title and the location, in order to link two things. So we basically performed entity linking between the two apartment websites, and we did this by comparing the title and the location of the two, and we simply used a similarity between the the locations and the between the two locations and the two titles. We sort of weighted that by an alpha. I believe this is simply a Jacquard similarity here, and yeah, then we also use blocking because essentially we have a lot of pairs to compare. So we used zip code based blocking to basically improve the time to 30 seconds. So blocking as always is important to improve efficiency. Okay, so this is sort of the ontology we came up with. It has the usual suspects again. So we have a an apartment. Apartments have floor plans. We have an apartment sort of finder that. So that's, I think, sort of the agent that is located in a certain location. And we have, I don't know, nearby, what is found nearby. So we have malls and parks and airports and things like that. And we have sort of celebrities that are born. This is the arrow should have been the other way around. So celebrities are born in a certain location, may have studied at universities and so on. So this basically, based on this ontology and based on the extraction, we come up with 46,000 nodes and 160 plus relationships. So they're not all shown here, but this is just an example to give you an idea. So let me talk a bit about the other things. So what are we really doing with this graph? So we collected all of this information. It has COVID information. It has I don't know, information on celebrities, on apartments, on sort of demographic stuff. So what can you really do with this? So we worked a little bit on different ways to do query matching by users, and we have sort of three different parts of this solution. So the first part is we look into keywords. So one way to use keywords is just to do information retrieval, to just find the keywords from a question of the user to the into basically apartment description. And okay, so this is one thing we did. So let's say the user writes this sort of query. I want an apartment near a shopping center with high security, things like that. Okay, so one way would be to just look those into the description of the apartment. But what we also did, we sort of defined specific keywords and we matched them to specific structured queries that you can run. So if somebody talks about security, we thought, well, probably they mean sort of confirmed cases and deaths of COVID-19, or maybe low crime rate and things like that. So we took this and we sort of mapped them to queries in our graph. Similarly for shopping. So if people start talking about shopping, we say, well, probably you want to have as many shopping malls nearby as possible, and things like that. So if you mention things like about social, stuff, then we want the median age to be, in a certain range, perhaps, or the proportion of married people should be in a certain proportion and things like that. Of course, tuning these, values takes a little bit of time, and it's an open question. But this is sort of one attempt to take keywords and do something structured with those. The next thing we did, sort of in addition, is we looked into entities. So this is where we, assume that people might sometimes look for things like a specific celebrity. So here is Nylon Pink. I have no clue who that is, but there is some celebrity, and somebody wants to live near them. So what do? We go to the Wikipedia and we sort of know where that person lives. Right. So we use that sort of as an additional indicator for us to do filtering. The other option is to look for sort of nearby locations. So we kind of use the entity recognizer to find these sort of cases, and then we use them to find nearby apartments. And then the third one is, if we cannot match any keywords, which is a reasonable expectation, we just run topic modeling with LDA, and that's how we basically match the query by the user to what we have in the data. Okay, so let me talk about use cases a little bit. So basically, how do we use all of these sort of system? So one thing that we can do is basically run a query. So you can basically choose your thing. So you can say, well, I want this floor plan features, just the usual things, whatever options we have in the data, we have prepared them, exposed them here. Essentially, in the special requirement, users write their additional query, which is then taken into account, as I talked before, based on keywords or based on topic modeling and so on. Okay, so this is sort of the one of the ways to use the data. It allows you to get this sort of interface, and we ran a small evaluation on this. So we took the top 50 results from 10 users. So we gave 10 users, a number of scenarios, and we compared the top results between them, and we saw that different retrieval methods have different accuracy here. So I left this out of the presentation just because of time, but there are details in the paper. This is another thing that I think just keeps coming back. So we always somehow, the temporal aspect is always there, but especially for these sort of applications, we always try to abstract over it. But I think here we try to look a bit into these two. So basically the question is, can we capture the spatio-temporal dynamics of the market? So let's say if we want to talk about debts, we basically have data from two different time points, or from November 2020, from February 2021, and then we can see that to some extent things are changing. So actually on this map, seems like most of the things are sort of very similar. There are some variations in these two circled cases here. So interpretation has to be added, I guess, but in a way this is sort of what we see. So if we measure the temporal dynamics, we see that things are changing. Similarly for prices, there is this part here that has become much more expensive over time, and this area here. So it seems like we could sort of model this. Of course, 2 time points are not enough, so I think it would be nice to do this over a range of time points and see whether this is a steady trend or not. But I think knowledge graphs really allow us to do sort of a bunch of these analysis just by changing the parameter or the query, and I think that is very useful for people that would like to buy or rent an apartment. Okay, so to conclude, basically what we have here is a knowledge graph based method. So we try to we basically thought of this as a general framework for housing market analysis that that has these components that I talked about before, starting from data acquisition and entity linking and semantic modeling. And then we use this for 2 use cases, one being personalized recommendations. So people have arbitrary flexibility to look for things. So you can have more structured query, but you can also sort of type your wish, and we try different sort of tricks to capture what the user perhaps meant. And the other thing that we looked into is this sort of housing market analysis over space and time with respect to different factors. So we believe that this could be reused and expanded easily. So for example, one novel use case would be the impact of regional education and climate on China's housing prices. Obviously the sources would have to be very different, but we think that much of the other things could be actually well, at least the pipeline could be reused, and then I think the components should be adapted. So perhaps easily is kind of with a grain of salt, but I think it is something that could be adapted to novel scenarios. So yeah, with that I'm concluding. Thank you very much for listening.
Thank you, Philippe, for your presentation. Are there any questions from the audience? I check out the chat. I don't see a question. I have one question, actually.
Mhm.
So you have two different use cases and you have two different pipelines that you follow on, like for generating the knowledge graph. But two different but similar. So if I would ask you to summarize, what are the differences and what are the similarities between the two approaches and why you made certain decisions on each case, what would the answer?
Right. So you mean the open track knowledge graph versus the
Exactly,
house?
yes. Mm-hmm.
Right. Yeah, I think so I think in general we try to follow a similar pipeline. So I think the starting point was sort of very similar. So I think the idea is you start with sort of a problem and nothing else, and then I think the first thing we do is we decide which sources would be useful. So we have a way to obtain the sources. So there is data acquisition step. There is a step of semantic modeling and entity resolution. So I think these are steps that are, I would say, more or less common for any such construction scenario. And I think then it comes to the use cases of this, and I think those are where we were mostly differing between the two applications. I would say that in the case of the housing market, it seems to me that there is a lot more things like time actually mean a lot, and things like factors that maybe come and go, like COVID, because in a year COVID won't really be, hopefully, a matter that we would be considering. And so I feel like the housing market seems to be much more dynamic. So I think there is that part where the temporal analysis plays a big role, and maybe here is really what you also mentioned before, Anastasia, that maybe we should basically consider this sort of re-importing, iterating over the data more often, and maybe even over the whole pipeline, because the COVID attribute might not be relevant soon, and then we might want to replace it with something else. And then I think in the open track knowledge graph, we looked much more into these sort of interactions of things. I think those are probably where most of the interesting things come into, because it's a much more sensitive domain in a way. And I think we want to, it would be good to not prescribe a drug that interacts in a bad way with another drug. So, it's a much more, much higher risk. So I think in a way, the way I tend to think about these things is that I think there is the step of basically coming up with the knowledge graphs are, largely shared, of course, with a lot of adaptations in what you do in each step. But I think the general steps are very much shared. And then I think when we talk about like how do you use the graph, I think then it's much more open. I mean, these days it seems like a lot of what we do to use the knowledge graphs relates to, as we talk in this session about like embeddings and things like that. So I would say things like computing embeddings, or handling user queries are always there. But I feel like still there is a little bit of more room here to kind of do something that is application specific. Sorry, that was a long answer, but
It was a long but good answer. Thank you very much for your presentations and for answering the questions.